So welcome to Co-working Night 41. So we have a lot of exciting stuff going on tonight. I'm going to kick it off. I'm going to do a presentation about Jupyter and scientific computing with Python. Coming up at 7 o'clock, Tom O'Connell is going to be talking. We're going to do a reading group or a discussion group, as reading is not required, of the Lean Startup. And then I think at 7:30, downstairs in the very back corner, there's the nice little comfortable area that Bond is going to be giving an introduction to stocks and trading. And so I think there should be a ton of people out for that. It should be a lot of fun, pretty exciting stuff. So tonight I'm going to talk about Jupyter. So just very quickly, so I know how to calibrate. How many have used Python? Python, MATLAB maybe? Yeah, a lot more MATLAB. So, is anybody familiar with IPython? I guess the predecessor to this. Okay, so the Jupyter project actually formed from a project called IPython, and I'm going to actually do everything in the Jupyter interface here this evening. So basically, back in 2001, some people started working on making the Python shell better, right? So in the early days, it didn't have very much. It didn't have tab completion. It was very inconvenient to use. And so people started building all of these add-ons for it, and it eventually grew into this thing called IPython, which is basically an enhanced way of interacting with the Python programming language. Since then, a lot of universities...
stand for interactive?
Say what? I think stands for interactive. I wasn't going to say that since I'm on video. I didn't want to be wrong, but that's okay. So since then, a whole bunch of people in the scientific and the academic community have kind of latched on to Python as a sort of de facto academic programming language and scientific programming language. And the reason for that is that Python is a very good sort of glue language, right? It lets you put together a whole bunch of modules that people traditionally used in the natural sciences like biology, geography, and then also ties in very nicely with sort of the hard computer science aspects, so efficient algorithms and data structures. So there's a whole bunch of libraries out there that make working with scientific computing in Python a lot more convenient. The big ones are the SciPy stack, which is NumPy, SciPy, Matplotlib, SymPy, and Pandas. And so basically all of those things together can replace MATLAB for free. So if you're like me and you work for an employer that doesn't want to pay $10,000 a year plus $2,500 per toolbox for MATLAB seats, this is an excellent alternative. And then what we're looking at here is actually the Jupyter interface. And so the progression of the IPython project eventually came to this very nice web interface, which for people who have used Mathematica or Maple is actually a pretty similar format. And so I'm going to kind of talk about some of the highlights of this interface. And so this is all in your web browser. This is running in a shell behind the scenes on my computer here. So basically, what you see is this is the Jupyter Notebook environment. So this is the web application front end of Jupyter. And then this actually connects to what are called kernels in the back end. And so originally, Python was the only kernel available. And since then, developers from all over the world have contributed 60 different kernels. I think last count was 60 or 61. And so Python is one of just many kernels that you can use in this same interactive format. And so it looks something like this. So here we have a cell that has Panda code in it, or Python code in it. And so we can write Python in there and it'll execute. So simple enough. On top of that, it adds a whole bunch of sugar for making your life a lot easier as a programmer. So if you hit Shift-Tab, you get documentation. The more times you hit Tab, the more documentation you get. So if you're really lost, you can just hit Tab a whole bunch of times until Python will tell you exactly what you're supposed to do in as clear terms as possible, which is not particularly clear for the function that I chose here, but that's okay. That's the benefit of doing live demos. So also it gives you tab completion. So if you need access to understand what methods are available in a particular module or class, all of that's available. Obviously, you can just execute normal Python code, define functions, define classes, and then on top of that, it has what are known as magics, which are these kind of particular functionality that are all prepended with the % that lets you do things that are kind of common tasks that you would do in programming. So here, I'm running a timing function for 2 different list comprehensions. So you can see, if you were developing a chunk of code and you wanted to see which one ran faster, you could write your 2 alternatives and see which one runs faster. So clearly, in this instance, doing a list comprehension is faster. Clearly, so there's also a whole bunch of reference. It lets you run different programming languages right in the same mechanism. So here we can execute a little bit of Perl code, we can execute shell code, and then we can execute actual shell commands. What's cool is that each of these cells can not only be code, but you can also write Markdown in them. And then this whole notebook format can be exported. So the reason that the scientific community has really kind of latched onto this is that you can write in this notebook. You can use this notebook both as like a lab notebook, which is something that's very important in science and engineering, but also when you go to publish your work, you can just dump this exact notebook, this format. We can just do a file, download as, and we can get a PDF file, or we can get a Markdown file, or we can get HTML, or we can export it to straight Python. So in each of these cells, we can do things like rich text, italics, and bold, links, equations. These equations are typeset with LaTeX, which is kind of the lingua franca of equation typesetting. Code with syntax highlighting, images. And then additionally, there's a little bit of sugar for like if you want to have enhanced output on your code. So say your Python code, rather than just outputting kind of blah text, you can output HTML and it'll render the HTML inline for you. You can output SVG and it'll render SVG for you, and you can do YouTube. And it'll render YouTube videos. And so this is all extensible. So as an end user, you can actually improve and add different capabilities as you see fit. So that's just a really brief overview. Yes?
Would you use Jupyter for full-blown development, or would you treat it more like a playground?
I use it more like a lab notebook would probably be the best way that I would put it. So a lot of like exploratory data analysis. So I can show you some of the stuff. We'll skip over some of just the library introduction stuff, at least very quickly. For those of you who use MATLAB and are looking for a free MATLAB replacement because you don't want to pay for MATLAB or your employer doesn't want to pay for MATLAB. So this is Python code, but for those of you who come from MATLAB land, this looks very, very familiar, right? So create a figure, plot X versus Y on a figure, X label, Y label, title, whatever. This looks a lot like MATLAB, all the way up to doing legends and labels, all of your different possible line styles, and it's syntactically pretty close. The marker plus and color, you can just do G. You don't have to do green. So it looks a lot like MATLAB in that regard. It's got a whole family of different plot types, statistics. Image processing. Well, of course, it's not going to work because it's a demo. So image processing, all sorts of fun stuff. So this, I would encourage you, if you're looking for a MATLAB replacement, and I can talk more about any of these functions, to dig in and talk to me afterwards, and we can talk more about specifically using it as a MATLAB replacement. Since Bond is doing stock stuff later, we can use all of these tools from the SciPy stack and do a little bit of stock analysis on our own. This is as rudimentary as it gets. Don't buy stock based on anything that I say. But that should go without saying. Let's see.
Does it support Python 3?
It does support Python 3. So this is all Python 2 because I never learned Python 3 because I'm a terrible person. Apparently GitHub is down.
Unicorn is ink.
What?
That is unheard of.
Your network connection maybe.
So,
No, because I'm getting the page.
that's a good point. Yeah,
Which page are you?
he's getting.
I'm getting a
404
page.
Well, not a 404, but yeah.
So
So
I'm not
GitHub is
actually
sunk
sure what to do in this case.
It is sunk to SourceForge levels.
Control R,
F5, F5,
F5.
F5.
You shut down and reboot.
3
Interesting.
times.
Answer to all life's problems. Turn it off and turn it back on again.
Go to some other
Yeah,
website.
GitHub is
just for
down. Like I can't.
Oh, yeah, significant network. Oh, look at that. That's bad news. So, the moral of the story is if you're going to do a live demo, don't depend on GitHub being up, I guess. 99.999% is just not enough uptime. All right, that's okay. I think some of the stuff is cached. Okay, so like I was saying with the other kernels, so this is an R kernel. R is a language that's frequently used in data analysis. Madhav is the R expert. He'll tell you all about all the cool things that you can do in R. I know absolutely nothing about it other than it's a single letter and it's really hard to search for on Google. Julia,
You
which
prefix
is,
with R, that's all.
yeah, R-lang, I think is what you're supposed to do. So Julia is another scientific programming language. So you can see that basically through the same interface, the same kind of mechanics where you input what you want to do and hit enter and it executes and you get output. This same sort of interface works for all sorts of different languages. Probably the one that's the most interesting that I don't have installed on here is Cling. So for me, I do a lot of C++ development, and it lets you write C++ and execute it interactively, which is super cool. You know,
Does it
normal
support Scilab?
Bash shell type stuff. So let's see, what can we do without GitHub?
So Jupyter just supports scripting languages.
It supports, well, C++ obviously is not a scripting language, so it supports a whole variety of languages through that same mechanism, right? So
it does compile C++.
yeah, in the back end, it's actually doing compilation to code and then executing that code in place, and then returning that output to you. So we'll go through some of these.
Can you show like how you start the Jupyter to get the you're hosting on localhost?
Yeah, so for me, I'm running in a, I don't know if you can see that. Yeah, so I'm running in a Docker container. So, but normally you can do, like, let's see, I gotta. Just do Jupyter notebook. It's annoyed because I've already got one running on 8888, so we'll have. So you get the same thing, right? I'm generating. This is day job stuff, so don't look too closely at it.
So you use PIP to install Jupyter?
Yes, yeah. And so version 4 just came out, so whatever you've got, whatever your operating system package manager has is probably out of date. So pip is the best way to go about it. Also Conda, C-O-N-D-A, is a good way to do it as well. So I'm going to try and recover from not having data here. Maybe it'll work this time. Nope. All right. Man, I had some cool stuff too. All right, so here's a little play at some data analysis that I did. So all of you are familiar with Tech 256. Most of you are familiar with Tech 256. So basically, some of the stuff that I like to do with Python is gluing a whole bunch of APIs together and doing data munging. Madhav and I have done some stuff with the Madison crime data. I've done some stuff with some FCC data that's out there, the public restaurant data. There's a whole bunch of fun data sources that are out there that we can bring in and we can visualize and we can play with in all sorts of different ways. So just as an example, since I knew a whole bunch of people from Tech 256 would be here, this is basically calling Slack's API. So Slack is the multi-billion-dollar unicorn company chat application, and so they provide a very sexy API that we can use to pull in a whole bunch of different data. So here is like kind of the raw unformatted data. So if we want to get all of the users that are in Tech 256, this is what we get, right? So we get one of these entries for each user, which is kind of crappy and it's hard to look at. And yeah, so we can reformat that using pandas. So pandas is a library for dealing with tabular data, basically exactly what we have there. And it formats it into, this is an example of using that inline HTML, right? So because it knows that it's being executed in an IPython notebook, rather than just returning text, it'll return rich HTML. So normally, pandas looks like this, which is ugly, or it can look like this, which is pretty. So we can do fun things with that. We can find all of the users that are active on Tech 256 and find their profile pictures, which...
The Slack API, is that the JavaScript API or is the Python API?
You know that guy? Yeah, I know a lot of these guys. Kevin and his excellent beard.
Oh, so excellent.
Yeah, and Kyle and Tara and Tyler and all of these people who are active on Tech 256 and not here tonight, right?
Oh.
Dan is downstairs.
Oh, that guy?
Yeah. So we can do other things, like we can get a list of the channels and do some data munging on that. So people who were on Tech 256 this afternoon probably have already seen the results of this, but I did some stuff like we can pull in all the channels, and Pandas has this querying language. So now that we have this tabular data, we can do queries sort of like SQL on this data, and it can handle very, very large data sets. So versus kind of built-in Python capabilities to Pandas, you can go to massive data sets.
You don't have to do anything. Panda will select this in, and then you can pretend it's SQL.
Well, you deal with it through the Pandas API, right? And so it can read from CSV, it can read from JSON, it can read from
But you just say,
SQL,
here's
it
some
can
data,
read from...
it reads it in, and then you can, wow.
Yeah, so, and then we can do all sorts of, it gets rid of, and that's why I like Python, it gets rid of all that crap where it's like, oh, I've got this, esoteric data format that I need to figure out how to get in so that I can actually get my work done. And so you can just skip over all that part to the get your work done part, right?
Yeah, a number of people contributed writing,
the
new date file format comes in, they put an API that will read it.
Yeah, and if it's not out there, I mean, if it's not built into Pandas, you can probably find it, right? Like you can go to PyPy and search for your esoteric file format of choice, like, I don't know, HDF5, right? So HDF5 is a pretty common, NASA uses it. They're big fans of HDF5.
Yeah, like all the scientific.
And so yeah, here we go. We got HDF5, and we can download it, and we can import it, and then we can interact with the data the same way at a higher level of abstraction, right? And so
That's impressive.
And so what I've done here is, so I've sorted the channels by number of users, which is not particularly interesting. The thing that I was looking for is the newest channels, of which I think you're responsible for like 3 of them.
No, well...
Yeah. And then, we can do more creative or more complex queries. So I wanted to find the channels with the highest number of active users currently logged on. And so that's what's happening here. So let's see.
Yeah, coming back to that question, the Slack API.
Yeah.
Is it the Python API?
No, it's just a REST endpoint.
Okay.
Like it's just a sorry. There we go. Web API. So it's just a REST endpoint. You push pull or get posts to it, and channel.create blah blah blah. Here's what you send it. Here's what you get. It's very well documented, right? So they're building their entire business model on being an application platform. So let's see. And then one last thing, since all of my actual demos that require data are not going to work. So is there anybody who does like Maple Mathematica stuff? Has done Maple Mathematica stuff? Yeah.
Years ago.
Yeah, okay. Yeah. So, yeah. What's kind of cool is that you can do symbolic manipulation in Python as well, which I find very useful because I frequently find myself computing very, very large derivatives. And so you can do things like ignoring all of the nastiness in between there, but you can define these symbols and you're actually telling Python, rather than these being variables, these are actual symbols that we want to manipulate algebraically or with calculus, right? And so we can compute these functions like f is sine of x times y and cosine is y times z, which is something that you would absolutely never remember how to differentiate because you haven't taken calculus yet, you never took calculus, or it's been a long time since you took calculus. But it's okay, we have computers, and so it'll compute the derivative for us, and we can move on with our lives and not have to pull out our calculus books. Same with
We don't want to do summations in real life anymore.
same with integrals, right? Yeah, none of that stuff. What's a derivative? Yeah, let's see. So if you're, this one doesn't take data. So this one is just I did a simple spring mass system, and by I mean I copied somebody's. And so this is kind of using NumPy to define this system of equations. And so our system looks something like this, right? Big old array, that's fun. And then we can plot it, right? So using the built-in plot functionality. So each of these balls is a mass, and the lines connecting them is a spring. So going back to our Physics 1 class, this is clearly not good because this is not an equilibrium state because there's gravity which should be pulling this beam down. So we can compute what the potential energy is in the system, which is negative 0.981, and physics being what it is wants that to be pretty close to 0. And so we can run that through SciPy, which has got a whole bunch of algorithms, notably for numerical minimization and optimization. And so we can come up with the equilibrium configuration for that same system of springs and masses. And you can generate animations, and you could generate all sorts of plots and whatnot, whatever you needed. And then at the end, you could dump this out as PDF and turn it into your professor or to your boss, and it gives you a nice formatted. Look at that. You could tell it's LaTeX because the font looks good. Right? This looks like something that your professor handed you in school, right? And
You do Comic Sans on
I don't know. I run Linux, and I think that hasn't made it over yet. I'm not sure. I don't think that's the thing on that side of the fence. So yeah.
Does it support Scilab?
What is Scilab?
It's equivalent to MATLAB. Free.
Oh yeah. Apparently nobody's getting anything done tonight. Yeah. I said that tonight was going to be the night I got something done at co-working night, and that's just not the case. So. Yeah, with that, any other questions? I don't want to bleed into Tom's time too much because I know we've got like back to back tonight. So
Bit buckets up.
yeah, bit buckets up. That's because nobody uses it. So yeah, any questions? Any thoughts? Basically, get rid of MATLAB, save a whole bunch of money.
He said, I got a question.
One in the back.
No one's got a question.
That was good.
Can you make GIFs and quickly export it to your social media so you can have like the bridge quickly like?
I'm sure that we could. Do you want to sit here and watch me live code that? Is
Yes.
that-
Hands
yeah,
up.
yeah. No, yeah, that's definitely. I think.
Yeah, the sky's the limit, really.
Yeah, anything you can do, and that's kind of the benefit of it, is anything you can do in Python, you can do in this notebook interface. It's just very, very convenient, right? And so some of the other things that I didn't touch on, it has the ability, so I don't have the cluster stuff installed, but you can actually spin up, rather than one kernel, you can spin up, 8 kernels in parallel. And so if you have a task that needs to run across multiple computers or multiple cores on the same computer or multiple computers on the same network, you do it through the same interface, right? So you don't have to necessarily like jump out of this one interface and then say, okay, now I need to go write a whole bunch of C++ code with MPI and all this stuff. And it just works from the same sort of interface, which is kind of convenient.
So in theory, you could, for not very much money on AWS, recreate Pixar.
And people do use this as a front end to AWS, right? So people do a lot of things with this. Let's see, I had probably one of the most notable examples. I don't have it saved in here. That's okay. So you can look up Peter Norvig, who is kind of the famed Stanford artificial intelligence professor. He has an excellent IPython notebook on the traveling salesman problem, right? So it's like an algorithms 101 class, right? And so the traveling salesman problem. Basically, the problem statement is there's a family of cities, and you know what the distances are between the cities, and you want to compute the optimal route between all the cities. And it's an interesting problem because it is a non-polynomial problem, which means that there's not a way to express the runtime of the problem, essentially. And so it's an interesting problem, but Peter Norvig is he has just a spectacular mind and a spectacular way of explaining these problems. He builds it up like step by step by step with graphics, and he uses the Jupyter notebook, the IPython notebook format to demonstrate that. And it is awesome. Let me see if I can do it really quickly. I can do it. I can do it. No, I can't. So also there's this NB viewer. So if you have a notebook and you want to share it with people and they're not Python inclined because they just haven't been enlightened yet, there is this NB viewer which will render, the IPython notebook actually stores each input and output in the file format. And so it will render, this whole thing is done in the same Jupyter notebook, the same format that I just showed you. And so he goes through and he writes code and he explains it and he does plots and it gets a little deep. It's a treatise on computer science and algorithms and optimization problems, and it's fascinating stuff. So this is a good kind of example. This is the one that I always point to when people are like, well, what can we do? It's got an XKCD comic. It does all the important things. And so like people say, what can we do with this format? Like what can we do with this? And like this is the example, right? And so you could see, doing this as a deliverable for an employer, doing this as a deliverable for data analysis to really show people. You can show people the exact steps. You can give them this thing, and you can say, look, you can reproduce this on your own data. You can replicate this using different libraries and algorithms, and we're going to come up to the same answer, and science is better because of it, right? And that's the sales pitch, right?
Reproducible research is very important. Yeah.
And I think Nature now is actually requiring people to submit code in addition to their papers.
Yeah, for all data analysis specifically.
Yeah, I'll have a summary of this. So
We
Yeah.
should,
move on. All right, so Tom is up next, and we're going to talk about Lean Startup, and then Bond is going to be downstairs in just a bit. So you're free to go and do things or hang out here and talk about Lean Startup with us. I think we're finishing up Lean Startup this week and moving forward. So,
good job.